Hi and welcome to this intro video on VR Tunneling Pro. I'm Luke, lead programmer at SigTrap Games. I'm going to briefly explain tunneling, go through the example scene that we include in the package, and go over some of the major features. So what is tunneling and why would you want it in your projects? Many VR players experience sim sickness. This is generally caused by a mismatch between what you see in the HMD and what you feel in real life. In short, this is caused by artificial locomotion. Tunneling is a powerful way to mitigate this effect. The brain gets a large amount of motion data from peripheral vision. When artificial locomotion is detected, tunneling dynamically reduces peripheral vision, and in doing so reduces the sense of motion. While this looks very intrusive on screen, it's actually quite subtle in the HMD. There are multiple ways of achieving this, and VR Tunneling Pro gives you a wide set of options. We'll explore these a little later on. This is the example scene in the package. You'll find it in VR Tunneling Pro/examples, and it's just called VRTP_example.unity. As you can see, it's a very simple scene. It's just got some level blockouts. And if I zoom in on the player object here, you see that that's also a very simple setup. It's a character controller with a custom movement script, which lets us move around with FPS-style controls and cycle through some demo modes using the number keys. VRTP is an image effect, and as such we place the script on the camera, as seen here. The important thing to note here is the motion target. Currently this is linked to the player transform. VRTP detects motion from the motion target. It uses this motion to drive the effect. As such, this needs to be something that's driving the artificial locomotion. In most cases, it shouldn't be the HMD, since natural head motion doesn't feel strange in VR. So for instance, in a racing game, the motion target should be the car itself, in a space sim it should be the spaceship, and in a first-person game it should be the player controller. The motion detection settings are fully customizable. By default, we just turn on angular velocity, i.e. turn rate, but you can also key the effect from velocity and acceleration. You can change how much each of these types of motion contributes to the effect, and you can also set minimum and maximum parameters on each. So now I've pressed play and I've got the headset on. The movement script will allow us to move around with WAS and D and look around with the mouse. We can also look left and right with Q and E. The other thing the script lets us do is change modes with the number keys. So as you can see at the top, we've got 1 is basic, 2 is skybox, 3 is cage, and so on. So to begin with, we're in basic mode, which is just color. In this mode, we draw a vignette around the screen to reduce peripheral vision, as you can see, and at the moment it's just black. But this can be any color you like, and we can also change the alpha to change the overall opacity of the effect. If we change to skybox mode, we're now drawing a cube map in the periphery, not just darkness. This is known as a cage. We use this to not only reduce peripheral motion, but actually replace it with a static reference frame. This helps ground the player by convincing their brain that the static reference frame is the real world, not the VR world. By pressing space, we can cycle through a few different cube maps, and these are the ones that we include in the package for you. Pressing 3 switches to cage mode. This lets you have a fully 3D cage, which gives you depth perception, head motion, and for a lot of players can give an even stronger reference point. It also means you can have dynamic content, move things around and change things, as well as just have more flexibility than a cube map. Pressing 4 goes back to the basic color mode, but now we've enabled masking. The green arrow object has a mask object script on it, which means that it's excluded from the vignette effect. This is really useful for objects which already form a static reference frame for the player, for instance cockpits, bodies, arms, and so forth. The masking mode is separate from the background mode, so we can combine them. In this case, if I press 5, we go to masked cage mode. So we've got masking on, but we've also got cage skybox mode. In the vignette then, we have 3D objects forming the cage, with a skybox drawn behind, and we've also got masking on the green arrow still. VRTP gives you multiple masking modes. So we have the basic mask object mode, but if I press 6 now, we're in window mode. Window mode means that the VR world is only drawn over objects with the masking script on. Therefore, we're providing a constant frame of reference behind the windowed objects, convincing the brain that the static world is in fact the real one. As we move, we see the vignette still comes in from the edges, and this is fully customizable. The final mask mode is portal mode. This is the opposite of window mode in that the effect gets drawn onto mask objects. We can use this by placing objects in the VR world to create static portals through to the effect. This helps convince the brain that the static world is the real one and therefore less motion is felt. Window and portal modes are described by Oculus in their blog post on locomotion research, which is linked below. Finally, by pressing 8 we switch to blur mode. This is a less intrusive version of the effect for players who might find the other versions distracting. It has a slightly weaker effect since it only blurs the background, but this can be enough for players with moderate sim sickness tolerance. So that was a quick look at VR Tunneling Pro. If you'd like more information, please look at the tutorial video, or check out our website, or see us on the Unity Assets Store. Thanks very much for watching.